For example 3, we have the diagram shows a section of orienteering course which outdoor education students have to complete for credits. The course is from A to B to C to D, back to B. Starting at A, students travel due north to B. At B, they change direction and head for C, which is due east of A on a bearing of 115 degrees. So I'm going to stretch out this line and say that this angle going all the way to here is going to be 115 degrees. At C, they change direction and head to D on a bearing of 15 degrees. So I'm going to stretch this out straight north and then say that this angle here is going to be 15 degrees. From D, students head back to B and angle C to D to B is going to be 40 degrees. Now, at this point, there is some other information that I can pull out of here. So at this point, I know that from A to B is straight up and down, so if I use my straight line rules from before, I can say that this angle in here is going to wind up being 65 degrees because they have to add up to 180. They're supplementary. The second thing that I know is that this is going to be a 90-degree angle, which means that I could say that the total angle at C from A to C to D going all the way through here is going to be an angle of 105 degrees. So, mark the given measurements on the diagram and explain why BAC is going to be 90 degrees. Well, I mean, it's obvious why this is 90 degrees. The reason why this is 90 degrees is because this is straight north and this is straight east. Angle A, B, and C, we've already explained why A to B to C is 65 degrees because of supplementary angles. Lastly, it's asking why is B to C to D going through here going to be, I'm going to use a different color for this, why is just this part 80 degrees? Well, the reason why that part is 80 degrees is because B to C to A has to be 25 degrees. Because these three angles have to make up the total 180 for a triangle. If we know that A to C to D is equal to 105, then angle B to C to D is going to be the same as 105 minus 25, which is going to give us that 80 degrees in there. For part B, use triangle ABC to determine to the nearest hundredth of a kilometer the distance between AB and BC. Well, let's add in some of the information we know for the distances. It says that from A to C is going to be 2.4 kilometers. So if I want to figure out what A to B is, well, this is just a right angle triangle. There's a whole bunch of ways that we can approach this. I could use angle C and say that tan of C is going to equal the opposite, that AB I'm trying to solve, divided by the adjacent 2.4, and I know that the angle of C is 25 degrees in this case. Which means that given this, AB is going to equal 2.4 times tan of 25 which is going to be 1.12 kilometers. The next thing I'm going to do is I'm going to solve for B to C. Well, I could use, once again, whatever ratio I want. Just in case I did A to B wrong, I'm going to use the angle C here, and I'm going to solve for my hypotenuse using that. So I'm going to say that, in this case, cos of 25 degrees is going to equal my adjacent divided by my hypotenuse. And my hypotenuse in this case is obviously B to C. BC multiplied by cos of 25 is going to equal 2.4, which means that BC is going to equal 2.4 divided by cos of 25, which in this case is going to give me approximately 2.65 kilometers. For the last two parts, it's saying use the triangle BCD to determine to the nearest hundredth kilometer what the distance of CD and DB are. Well, I've already solved one side of this, which is going to be the B to C is 2.65. And then beyond that, I know the other angles in here. There's going to be an angle of 115, an angle of 80, and an angle of 40. So I'm going to translate that to this page. I'm going to say, well, I have my angles. So I'm using the shared side length, 2.65 kilometers. I have my angle of 80 here. I have my angle of 40 here. And then from that, I know that this last angle is going to be 60 degrees. Here's my point B, here's my point C, here's my point D. So, if I know an angle and its opposite, and I'm trying to find the other ones, I can just use my sine law to solve for both of these. I can say that if I want to solve for CD, CD divided by sine of 60 is going to equal 2.65 divided by sine of 40. CD is going to equal 2.65 multiplied by sine of 60 divided by sine of 40, which means that CD is going to approximately have the length of 3.57 kilometers. For that was CD. For dB, same process. dB divided by sine of 80 will equal 2.65 divided by sine of 40, which means that dB is going to equal 2.65 times sine of 80 over sine of 40, or dB is going to have a length of, in this case, 4.06 kilometers. Now, if I'm going to calculate to the nearest tenth the total distance traveled while completing the course, then I'm going to just add together all the distances traveled. So for the first stretch, where they headed from A to B, I traveled 1.12. Then they traveled 2.65 to C. Then they're going to travel 3.57, not 75, to D, and then they traveled another 4.06 back to B. They traveled 11.4 kilometers. And that is it for trigonometry.